So cute.
Okay, I think we are ready now. Okay, the Graduate Management Admission Test is used as an admission criterion in many Masters of Business Administration programs. The scores that the GMAT in the past have a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. Okay, A. Determine the null and the alternative null hypothesis. So the null would then be 529, a mean score of 529. And the alternative hypothesis would be
You okay?
that greater than 529.
Yeah.
Yeah.
Is 529. I'm like, trying to figure out how to describe that on the thing. Okay.
So I wrote
that's
down
right.
the mean is equal to 529, and then the mean is greater than 529.
Well,
Yeah.
perfect. That's a great way to explain it. Okay.
All right. I can go next. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam was 529. Was it type 1 or type 2 error committed? And that would be a type 1.
That's what I got.
Yep.
Do you want me to do C?
Sure.
If the analysis was done at A equals 0.01 level, what is the probability of committing a type 1 error? About 1 in 100 or a 1% chance for a type 1 error.
Yep. Is that what everybody got?
Yeah.
Okay. If we wanted to decrease the probability of making type 2 error, would we need to increase or decrease the level of significance? And I said increase.
I agree.
Yeah. Okay, that would be me. A study by the National Association of Realtors reported in 2004 that a second home sales accounted for more than a third of the residential estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming that the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment properties in this area is different than the national average. He randomly selected 15 of his clients who purchased an investment and obtains the data shown. Design a study. What is the population from which the realtor obtains his data, and how did he sample this population, and what is his research? So the population would be sorry, the
Would it be
where he's counting from?
Would it be the people who are buying the second homes?
Or would it be his clients? Or would it be
let's see. How did he sample his population? That's where he took it. How he sampled.
He did simple random sampling, didn't he? Because he randomly selected 15 of his clients. So his population are his clients, and then he selected 15 of them.
That's what I got.
Okay, and then, so he did SRS of his clients. And the question is if the average age was different than the national average. So U is not equal to 47 years. Is that right?
Right.
Yeah.
We all sound so sure on this.
Well, it's because it's like one of those like super long questions, and you have to like.
Think through it, yeah. So, when you go over this just one more time, population is his clients. He did a simple random sample of his population, and the question is if the average age is different than 47 years. So that means that the mean is not equal to 47 years.
Right.
Okay.
Right.
So collect the data. Name at least one way the realtor could have randomly selected the sample. I don't even know if I wasn't quite sure on this one.
Does it mean like is it asking like could he have done a cluster sampling or a stratified sampling or
Or like not done his own clients. I don't know.
yeah. Or
I
is
think systematic.
that what it's asking or is it asking like he could have taken clients all over the world or I guess his question is if it's that his investment property area in his area is different. So, what did you say, Beth?
I said systematic. Because it's
Okay.
asking how he could have selected his random sample. So it's got to be one of the sample methods.
That makes more sense. Okay. All right, Susan is gone, so let's skip her.
All right. Describe the data, graph the data on the histogram, sketch the histogram below, or cut and paste your electronic copy. In a short paragraph, describe the data by using at least 5 descriptive statistics. So I did the graph part. Hold on. How do I share my screen?
So up on the left, there's a green. Do you see a green screen with an arrow in it? It's the second one down.
You see?
Oh,
I can do this.
Yes. Turn your phone the other way.
Oh, oops.
Oh, nope.
Oh,
Only a quarter.
right there.
There you go. Okay.
That's how my graph turned out. And I am a little unsure about descriptive statistics. Do you know what they mean by that question?
I'm afraid I don't. I'm a little bit confused on some of this stuff. I just do not understand it.
I know.
Okay,
'Cause
descriptive.
I feel like the questions are like almost like either super easy or they're trick questions. And they probably aren't either, but that's what it feels like to me.
Descriptive statistics. Okay, I'm looking at our lesson.
Okay.
I found the test statistic that equation that they give us.
One that looks like a z-score.
Yeah,
And then,
not what they're asking for.
yeah. Can I see your graph again?
Yeah. Bum, bum, bum. Here we go. Camera. Green. Hold on, I need to scroll up to it, or wherever it is. Okay. Can you see it?
I can, yes. Okay,
So do I just...
so it says 5 statistics. Our statistics are like, a mean is a statistic,
I've got 3 right there.
deviation. So we have those 3, right?
Yeah. So
And then-
the sample is 15. The standard deviation is 8.827. The mean is 4673.
What is, say, the minimum? Or Q3, or we have the mean. We could describe it using an outlier.
Okay. So I think the minimum is 27. And the maximum is 58. 58.
Okay. I think that would be enough descriptive.
Yeah. Susan, do you want to go since you were gone?
Sorry, the sister missionary stopped and dropped off a skirt that they need repaired. So that's where I was. Which number are you on?
What,
We're on
2D.
D.
2B?
D.
Okay, thanks. This will be making inference. And did you make your QQ plot?
No, see, that's about as far as I got. Did you make a QQ plot?
I did not.
Susan, did you make a QQ plot?
No,
Okay.
but I know I needed to do it. And then the state, are we doing 2 or is someone else doing it?
What's the QQ plot again?
It's the little circles along the line or away from them.
Oh, okay.
Okay.
And it checks for normality.
Oh.
So I could probably make that chart.
Oh, God.
Well, if you do it in SPSS, you can do, where is it, in Explore, in the graphs.
Do you have to use an SPSS in the test?
Yes.
Yes, you do.
So make sure you open your file before you start your test.
Is it the box
The
plot?
app will open too. It tells you that in the directions. So,
Or is it the scatter dot?
yep.
That's the one.
No, it's called the QQ plot.
Wait a minute.
It's,
Well, there's not one here called the QQ plot.
yeah. You analyze descriptive statistics and QQ plot.
Aha, okay.
You find it?
Yes. There's that. Here we go. It looks pretty normal.
Are they all on the line? Good.
Yeah.
Yeah.
Not all of them. There's a little outlier there, but for the most part, it looks normal.
Well, yeah, I guess there's like two little outliers. One at the top and one at the bottom. There's one there.
Now, there's not a lot of curvature anywhere.
Yeah, I would still say it's normal.
Yep.
Yeah.
All right.
Okay, so state the null and alternate hypothesis. And is this a one or a two-tailed test? The null hypothesis mean would be 47, and the alternative hypothesis would be mean does not equal 47. And it's just one-tailed, isn't it? I wasn't sure on that.
Yeah, I don't get that either. I think it's one-tailed, but because it's either or is it?
Let's see.
Hold on, let me go back.
I think it's two-sided.
Oh, because it has a not equal to, and in the notes it does say that if it's not equal to, it is two-tailed. If it's left or right, it's one-tailed.
Yep.
Okay.
So this is two-tailed, right?
Yeah.
Right.
Okay.
And, for the first one of those little questions, when you said check the requirements, was that the reason why I did the QQ plot?
Yeah. So, like, the requirements for that would be, like, if it's normal or not normal, right?
Right.
What significance level did you get? I had 0.05.
How?
As far as requirements, do we need to check, like, the requirements meaning, like, is it a simple random sample? Is the deviation known? Or is that what we're looking for? Those aren't the requirements we're testing for, right?
Yeah, they have 3 requirements.
Right. So the so back to 1, you're asking if the requirements are met, right?
I don't know where we're at.
For the QQ plot, right?
Right. So I made that plot and I didn't know why, and so when I went back to our assignment, I didn't see it asking for a QQ plot anywhere, so I was like, what? What am I doing?
Oh.
Oh, that was from 1 for checking the requirements.
Okay.
It just
Okay, here's the requirements.
backing up the thing that it was normal.
Because we wanted to know if it was, if the population was either more than 30 or if it was normally distributed.
Yeah.
So that so when we did the QQ plot, it told us that it was normally distributed, so that checks one of them.
Yeah, because there was only 15 pieces of data.
Yeah, and we know the standard deviation, which is 5, and it was simple random sampling. So the requirements are there. That makes sense.
All right, perfect.
So it's my turn. Okay, so the level of significance is 0.05. So it is within the parameters of 0.01 to 0.1. So the significance is not, I don't know, normal significance? Like, how do I say that? It's within the parameters, or
Little girl.
the level of significance is high, or...
It's higher. I don't think there's actually anything we're supposed to write here.
Oh.
It's just that the level of significance is 0.05. We're going to be using that later.
How about toy?
And how did you find that?
Well, it's the level of significance is on there. It's telling us the level of significance is 0.05. So we're kind of looking at it as information. not to find
Oh,
it.
okay. Okay. I was like, what?
And I was confused too until Beth said that, and I'm like, oh, that. Okay, so compute the test statistics. Blah, blah, blah. What is the formula to be used? So this is the one where we use the z-score formula, the long one. And so we do z equals x minus u over q divided by the square root of n. So therefore, z equals 47 minus 47. Is that right? Divided by 5 divided by the square root of 15. My only question is it 47 minus 47?
Is she excited?
I think so because it doesn't give us any other number.
Was the mean 46.73? Was that for different?
It's
In the box at the end, at the bottom of 3?
Bottom of 3.
so
Bottom
for
of
my graph, the mean is 46.73.
So would it be 47 minus 46.73?
Why would it be 46.73 again?
Because that's
So
the mean.
the graph that I took, it also gave me the mean, and that was, so the mean for our sample is 46.73.
Okay, so yeah, let's try that. So 46.73 minus 47 divided by 5 divided by the square root of 15, right?
What?
Which would give you 0.20914.
Wait, did it give you the standard deviation? Oh, 5. The national is 5, but the one we got is higher for the sample. That's confusing. Do we use the national standard deviation or the one that we got for our sample?
I think we use the national standard deviation.
Okay. Okay. Awesome. You got it.
So I got 0.2091, is that right?
That's what I got.
That's what I got.
Okay. Who's next?
I think it's me. So calculate the p-value. First, sketch a standard normal curve, graph, and test your statistics along the horizontal axis. Shade the appropriate area under the curve. Use the normal probability applet to compute the area under the curve. So the area, so I plugged it in, 0.2091 into the applet, and then do we shade both sides? Let's see.
So it's a two-sided thing, right?
Okay.
Two
Yeah, so
tails.
you shade both sides and leave the middle open.
Play in there, okay? Please.
So the area is 0.8344.
I think that's right.
Okay.
It's as far as I'm understanding that we need to shade the right and the left. But that's a rare event. Is it the same? Because when I was reading the notes, it was to shade the right and the left, that would be a rare event. Is that what it means?
So you're supposed to shade the right and the left when
When it's not equal to, right?
yeah.
And it's not equal to, and it's two-tailed, but it also says in the notes, I don't know. I'm just going to go with it.
Yeah. I can't believe I've been studying this lesson all morning since like 6:30.
I think I started at 7, but I did take a break to go see my daughter get her honor roll award, but
It must have been nice. Step away.
yeah, except for apparently I could have used the extra time. I'm glad that I got to what's here though. Okay. Is it Beth's turn or my turn?
I think it's my turn.
Okay.
Okay. So compare the p-value to the level of significance.
Oh, so this is where we use the...
Okay, so the level of significance was the z-score, right?
No, it's...
No, it's at 0.05.
5.
Oh, you're right. Okay. The p-value is 0.2901, right?
No, that's the area that we just got, so 0.83.
That's the Z. 209 is the Z-score. And that's what we put in the applet. And that's what
Okay.
gave us the area of 0.8344. So that's what we're comparing.
The
Yeah.
area is what we're comparing, okay. And that was how much?
It reads p-value is greater than the level of significance. And so we had 0.8344 is greater than 0.05. So we fail to reject the null.
Awesome.
So your arrow's pointing to the right.
I'm so confused on this stuff.
Do we reject the null hypothesis or fail to reject? We
Fail to reject the null.
fail to reject the null.
Yeah, because reject the null if it's less than the level of significance.
So we reject the null because it's, I mean, my brain is killing me. So the null was that it is not 47, right?
Right.
And it is 47?
No.
Oh my gosh, I have no idea what you guys are talking about.
I don't know what I'm talking about.
Not saying you're wrong. I was like, yeah, what?
No, because if we fail to reject the null, that means that the average of all his clients is 47, just like the national age. But I'm completely not organized with this problem, so I can't actually see what we're talking about in front of me.
Oh, boy.
Okay.
So we have insufficient evidence to conclude that the mean age of people buying a second home is different in this area than that of the national average of 47.
I'm gonna go with that because I have no idea what we're talking about. I'm looking on number 4 on the steps to it. Reject the null hypothesis if p-value is less than the level of significance. If not, don't reject it. So, like Susan said, we are failing to reject the null because the p-value is more than the level of significance, according to my notes.
And if it was less than, then it would be rejected.
Yes, so if p-value is less than the level of significance, then we reject the null. However, if it is not, don't reject it. So we fail to reject the null, as Susan is correctly stating.
Just because
Alright.
I wrote down what was in the book.
So, the next question is state your conclusions in terms of the alternative hypothesis.
In layman's terms, we say we don't have enough evidence.
Right.
Awesome.
I should say that to my children, but I don't really know what I'm talking about. I'm going to do what? I'm sorry, I failed to have enough evidence.
Presented insufficient evidence.
You could turn into the statistical mama.
That's good.
What action, if any, do you suggest the realtor take based on your statistical evidence? Well, since we don't have enough evidence, I'm going to say just keep doing what you're doing.
Yep. Make no changes.
Because even if our mean is close, I mean, what makes more sense to me is the fact that the mean, while not exactly 47, was close to 47. So on average, he is still targeting the correct group of people.
I
Does
should
that
really
make-
start taking notes.
You should start- Who was that? So, since we all feel wholly prepared, should we start our group thing? I almost don't even want to do it right now. I'm so confused. Okay.
Let's do it.
Let's listen to Beth. Okay. I'm going to have to go back and reread some of this, I think.
Yeah, me too.
All right, group meeting. We're going to start on our group meeting, not on our homework.
Let's see how many questions there are.
I was hoping for like 3.
21.
There's 21?
What happened to 10?
I know.
Ah,
Look at us murmuring.
I'm really good at that today.
Me too.
I can do question 1. I have completed the individual preparation, although I don't understand it. All right, let's start with number 3. Sorry, go ahead. I think I did the last one.
Okay, a hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo?
I know this one.
It's
Shoot, me
null
too.
hypothesis. Right?
That's the question I wanted. Okay, who's
You can do the next one, it's easy too.
okay? The which hypothesis involves equality? Is that the null one too?
The null.
Good job!
So,
As long as we all agree, we can't be wrong, right?
is the 3 the null?
Yeah.
And
I will find Olivia. She disappeared on me. And then 4 is the null?
Mm-hmm.
Okay, thanks for letting me catch up.
Now it's your turn.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that is actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true?
Easy.
The null? Is
I know that one too! Woo!
that right?
Yeah.
Oh, good.
Okay, my turn. Suppose the null hypothesis is hypothesis O, mean equals 10. Use this information to answer questions 6 through 8.
Stay here.
Which of the following represents the alternative hypothesis for a two-tailed test? That would be mean is not equal to 10.
Wow. Hey guys, apparently we know more than we thought we did.
Well, this is just the beginning.
The third one, right?
Hopefully they all stay like this. I'll knock on wood for us.
Okay. Which one of the following represents the alternative hypothesis for the left-tailed test? And that would be less than.
So the first one,
Yeah.
Yep. Okay, which of the following represents the alternative hypothesis for a right tail test? And that would be greater than, which would be the second one.
Right.
So, Susan.
the outcome of the hypothesis test is determined by comparing the p-value to the level of significance, or A. Use this information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis? So if the p-value is greater than A, the first one?
Yeah.
Yeah, we did that one, didn't we?
Yeah,
we were
did
just
it
talking about it, yep.
in the section
Susan's
2.
the expert on that.
Huh? Yes.
And then 10
Is that me?
would be the second one, because it would be less than the level of significance. Right?
Yep, sorry, Beth, you have to move on to the hard one. Wah-ah-ah.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use the information for questions 11 and 12. Which of the following would be the appropriate alternative hypothesis? Ooh, okay, easy. So they're claiming that it's more than 1,500. So that's going to be the third one there, right?
Yeah, I agree.
And then the appropriate null hypothesis
That'd be
is
less.
equal.
Oh, it's equal, yeah.
Boom.
Okay. Not the amount is equal to, okay. The insurance company randomly selects 40 claims and calculates a mean sample of X equals 1,650. Use this information. The insurance company assumes that the distribution of the sample mean is normal. Is this a good assumption? Yes, it is, because it is more than 30.
Yeah.
So no matter what, the law will, the central limit theorem will, oh, sorry.
That's
My bad. I didn't read the next question. Okay, who's next?
What does what theorem or law justifies your answer to the previous question, the central limit?
Good job. I agree.
Let's see.
Is Susan gone?
No, I'm here.
See you later.
So 13, you said yes for normal.
Yep.
My husband came home from work, sorry. And then the theorem,
I love it when that happens.
The central limit.
14 would be the central limit theorem, right?
Yep.
Are you being facetious? Because I love it when my husband comes home from work.
I'm glad to see him.
No, I really do love it when my husband comes home.
Me too. Okay.
The test statistic is, I don't know.
Would that be what?
N?
What?
No.
What's S?
Isn't it Z? They're just throwing random letters at us now.
Let's see. You find.
Statistic.
Well, the formula for computing the test statistic is Z equals,
Yeah.
and then the hypothesis test.
So it'd probably be Z.
So it must be Z.
It'll have to, because the N equals,
Different than the Z score.
yeah, because the mean up there is X. The randomly selected claim is N. Who knows what S is? So I think Z is right.
Oh, I'm sure there's an S coming.
It's
I mean,
Z.
the value is like the same as area, so.
It's for sure Z.
Okay. Good news. Is it? Yeah, go for it.
Okay. The historical mean of sales receipts at a grocery store is $150, a standard deviation of $40. The store manager suspects that the average has decreased. She set up a hypothesis test with the following hypothesis. Mean is equal to 150, mean is less than 150. She will use a level of significance of 0.05. Then she will take a simple random sample of 36 sales receipts from her store and computes the sample mean is equal to 144. Use this information for 16 through 18. What is the z-score associated with this test?
Okay.
All right, who's got a calculator?
I'll pull mine out, but somebody else do it with me, so we do it. Make sure we get the right answer.
Right. So we do the sample mean, which is 144 minus
150.
150, and divide that by 40 divided by the square root of, where is that sample size? 36.
Okay, my answer is -0.9.
I agree.
Okay.
All right.
Now, wait a second. I got lost on the bottom part of the equation. You got 150 minus 144, and then what do you put on the bottom?
Wait, it's 144 minus 150.
Why do you do it that way?
Because that's x. Sorry, go ahead.
The sample mean minus the historical mean.
Because it says z equals x minus u, and x is 144, divided by q, which is 40, divided by the square
Is
root
that the sigma for the standard deviation?
of q.
Yeah, that symbol. It's a sigma symbol.
Oh, it looks like an upside down.
40 minus 40, what do you do?
40 divided by the square root of 36.
And where do you get 36?
It's the sample mean.
There
It's
you
the
go.
sample size.
I get too flustered too easily. All right, thank you.
Yep.
So that's
Okay.
-0.9.
Yeah.
So, do we have to put a negative in here?
Yes.
Yes.
Okay, so
So-
what is the p-value, right?
Since we're looking for everything less than 150, does that mean we do the middle? No, we're doing just the left side, and then the z-score is -0.9. Is that right?
That's what I think, yeah.
By 0.184.
That's what I got.
.184.
Okay, number 18. Whose turn is it?
I'm not really sure.
All right, I'll go. What inference would you make about the null hypothesis? And I would say, hold on, Susan, I'll get this. We're going to fail to reject it because the p-value is not less than the level of significance. Hold on. Wait. Reject the null hypothesis if p-value is less than the level of significance, and it's 0.184. The p-value is 0.05, so it's more, so we fail to reject it. That's my final answer.
All right.
But do you agree?
It's what was written here. It sounds good.
Alright.
So what did you get for 16 and 17?
16 was -0.9. and 17 was 0.184.
But do you need to have the, are they asking for the probability or the P in 17?
Yeah, the p-value, yes.
So is that the top of the applet?
Yes.
I didn't get that.
With
It's
the
equal.
left side shaded only.
Yeah, I had that negative
In your-
0.184, and then I had, it was 0.4270 at the top.
Okay, what's your z-score that you put in?
0.184 negative.
No, the z-score is negative, is 9.
Oh,
The z-score is 0.9, so the p-value, put that in and see if it comes up with 0.184 on the top.
yes. Thank you. Jeez.
How come you're crying? How come you're crying?
Okay. Number 19, there are two types of errors that can be made when performing a hypothesis. Which one involves rejecting the null hypothesis when the null hypothesis is true? And that's type 1.
How come you're crying? Huh? Grandpa make you stay in the kitchen?
Yeah?
Okay. You all right?
Okay, Susan, do you want to do number 20?
Sure. A researcher decided that instead of using the level of significance of A equal 0.05, he will use 0.01. Which of the following will be true? You can draw there. I have no idea. I'd say the probability of a type 1 error will increase.
That means that it's a higher probability of rejecting the hypothesis if it's true. The null hypothesis is p-value is less than the level.
Or would it be?
I think it's the second one.
Why?
Because when you lower the level of significance, then that decreases the chances that you'll get a type 1 error, but it increases the chances of getting type 2.
But in
Yep, I agree.
One part 2C, it says if they did the level at 0.01, that there would be a type 1 error in our preparation.
Huh?
On page 2. I just went back to my notes. So you think it's the second one?
In the math, in the homework?
Yeah, in the preparation we just did.
But there's only a 1% chance that it would be a type 1 error,
Okay.
which is not high.
Your pencil poke you?
So you're saying the second one, the error will increase, type 2 error.
I think so.
I think so. I'm looking at my notes again, but
That's what I got from what it was saying in the lesson, but
Okay,
I
let's
could
repeat
have been
D.
wrong.
If we want to decrease the probability of making a type 2 error, we would need to increase or decrease the level of significance.
okay, it says here, if the value A, the probability of committing a type 1 error, is very small, the probability of committing a type 2 error will be large.
Say what?
So it will increase.
So it will increase, so that is right. Conversely, if A is allowed to be very large, then the probability of committing a type 2 error will be very small. A level of significance of A equals 0.05 seems to strike a good balance. However, yeah, I think that it's number 2, reading this again. That's what I'm putting anyways.
So, number 21. I'm not sure how they want us to put it in there, like as a percentage or as a fraction.
Like 1/20th.
That's true, because usually it says don't put percentage sign.
So isn't the value 0.05?
Yeah.
That seems a little bit too easy.
But that's what it is. We could put in 0.05, we could put in 5%, or we could put in 1/20th.
Well, since neither of the other ones work, we'll have to go with the first one. All right. Does that look good to everybody?
Are you putting it in as 0.05?
I am going to put it in as 0.05.
The percent sign doesn't work in there, so.
Oh, it doesn't? Huh.
And then 19, you had type 2?
No, type 1.
Fine.
Right.
All right, I'm going to submit it. Hey, I got
Hey, yay, I got it.
it. Phew!
You know, this is actually quite astonishing.
I know. I was thinking I'd get a C.
Stop it.
I was not at all confident in our abilities this week.
Wow, I am impressed with you ladies.
You are?
Yes, very.
How about us, ladies?
Rather.
All right.
So, what have you learned that's helping you